We're going to start with lesson 7, which is called the chain rule. This is the last lesson in this unit. It's not particularly hard, but it's about doing like nested derivatives. That's how I like to think of it, okay? So what I'm going to do is I'm going to skip the introduction up top for right now. I'm going to do that tomorrow, and I'm going to stick today to like the functional nuts and bolts to see if you can pick up the pattern of the chain rule. If you understand the pattern, it's going to set in your brain a little bit easier than if I jump into notation, because the notation is going to seem confusing to you and turn you off to the topic. Whereas this is really just repeating the same thing over and over again if you understand it. So I'm going to skip down here to this very important, what we call theorem, that's called the chain rule, right? And the chain rule is defined here, right? So I'm going to zoom in a little bit so you can see that, all right? So this is what we are going to call the chain rule. Let me let that focus. So it's when you have a function, like an f of g function where g is inside of f. What's going to be interesting about this is that you're going to have to recognize that I gave you an f of g or a g of f type function. And that's what we're going to use some colored pencils to kind of distinguish that, outer and inner functions. So I'm going to draw a little picture right above this to see if this makes sense to you. Actually, no, I'll draw it on a little card. That way I can always come back to it. Okay, so this is what I would describe as the formal definition of the chain rule. I'm going to give you a visual one, all right? So if you could look up here, that's in color, it kind of means a whole lot. So here is my visual definition of this, all right? Now, what you're looking at is my interpretation of what a chain is. So a chain is linked together with circles. Okay. The first function that you're going to do is you're going to take your outermost function and you're going to tell me the derivative of the outermost function. So here's my f prime. However, what is on the inside will still be untouched. The inner function will remain whatever g is, and then there can be even an inner function that we call h. Those will not have any change in their notation. Then we're going to move over to kind of the next multiplication within the chain rule, and you're going to be able to take the derivative of whatever the g function was, but keep its inner h function untouched. Then lastly, take the multiply by the derivative of the h function. This is my visual for it, okay? And I'm going to show you how it works on every problem and try to match it up that way, okay? So let's take a look at an example. I'm not going to use the notes. I'm going to go to something different. I'm going to go to the chain rule, my own little picture here. Okay. Now, the key to being able to do the chain rule is to recognize what is the outer and what is the inner function. Okay. So my outer function in this example is going to be this red quantity squared. my inner function is going to be 3x minus 1. So now, if I function on quantity squared, right? So over here, I'm going to put this in quotes. Quantity squared. How would you, sorry about that, stupid quote. How do you take the derivative of anything to the second power? What's the rule? Power rule tells us to do what? Like x squared. The derivative would be to multiply by 2 and then subtract 1 from the exponent, correct? The power rule. So I'm going to do that here. I'm going to take my red outer function, I'm going to multiply by 2, and I'm going to make this a 1. But if I look at my chain that I have right here, notice my g function remains exactly the same, untouched. So my g function is 3x minus 1. But now I need to multiply by the derivative of g. So the derivative of g is simply 3 plus 0. The derivative of 3x, the derivative of negative 1. Okay. Now if I go back to my math, something to note, I don't have any inner function that's green. So I only have a chain made up of 2 links, the red link and the blue link. So now when I multiply this, I'm going to get 3 times 2 is 6, 3x minus 1, 18x minus 6 is equal to y prime. That is an illustration graphically down here, but then I matched it to the colors here of what we are doing with the chain rule. Anyone have a question on that? Go ahead.
Is there no h?
There's no h function, right? There's not a third inner nested. We will get to some like that, but I just wanted to give you the visual from the front end. Okay, there is no h. All right, so now let's take our basic problem that we just did and let's step it up a notch over here. Very similar format, but now I have a coefficient and now I have a weird looking exponent. Okay. Here's the deal. This is my outer function. So there's going to be my f function, my red. My inner is going to be this. And again, I don't have an h function. I only have the 2 chains, a red chain and a blue chain. So now when I go to multiply 1/2 times negative 2, I get negative 1 raised to the negative 1/2. Because I take 1/2 minus 1, that's my power rule. But if I look back at my illustration, g needs to remain the same. I don't take the derivative here. So this is going to be 6 minus 3x squared. But now I need to multiply by the derivative of the blue function. So that's going to be 0 minus 6x, which my 0 I can kind of get rid of because I don't need it there. All right, let me just pick this up just a smidge so we can get a little more space with our writing. So now I can simplify this. I've got negative 6x over here multiplied by negative 1 is equal to a positive 6x. And I'm there. I'm going to put an or here because depending on the textbook or your professor or otherwise, they may want you to write this as 6x up top, and in the bottom would be the square root of 6 minus 3x squared. These are the same thing written in different forms. I'm pretty sure Delta Math will take it in the first form, but I wanted to make sure that I reminded you of negative exponents and fractions, how they work their other forms.